all, here we are solving a problem number 54 and set number 1 civil engineering question paper of GATE 2022. We will read the question first. A square concrete pile of 10 meter length is driven into a deep layer of uniform homogeneous clay. Average unconfined compressive strength of the clay determined through laboratory tests on undisturbed samples extracted from the clay layer is 100 kPa. If the ultimate compressive load capacity of the driven pile is 632 kN, the required width of the pile is how much? So answer should be given in mm. You need to remember these units. Now additional information is what? The bearing capacity factor NC equal to 9, addition factor alpha is 0.7. So now 1 minute. So let's just denote with some letters here. So a square concrete pile of 10 meter length. So let us give L for this, and then it is driven into a deep layer of uniform homogeneous clay. What is homogeneous clay here? So the clay which has same strength at every point in every direction is called as homogeneous. So now the unconfined compressive strength of the clay is given as 100 kPa. This is denoted as Qu. Okay. If the ultimate compressive load capacity, that is, let us say Q of the pile is 632 kN. Now we have to find out the width of the pile. First of all, you need to know how does that pile look, square concrete pile. Then we can understand what is the width of the pile here. So let's see the figure first. A rough diagram I can show you here. So it is not to the scale, but it's okay, I'll denote by. So this is length, this is width. B, let us say this is B, because this is square, everywhere it is B, and length. So we need to find out here B. So now we are clear about the given data and we know what is to be found out. But before that, we will understand what is Qu. What is Qu? Unconfined compressive strength of the clay. Let's see what it is. So first we'll see what is the unconfined compressive strength. Unconfined compressive strength, which is denoted by Qu, is the load per unit area at which an unconfined cylindrical specimen of the soil will fail in simple compression test. So this test, for this test, the detailed information is given in any standard soil mechanics books by Arora or Gopal Ranjan. You can go through all those books. And here let us take a cylindrical sample. This is the cylindrical soil sample. Now the test is done by just applying a simple vertical compressive load. There will not be any other load on other sides. Now if you see, this is the plane which is horizontal, this is the plane which is vertical, this surfacial plane. So you know, we'll discuss, along with that we will discuss the concept of Mohr circle also. So what are the axes for the Mohr circle? This is sigma and this is tau, whereas sigma is normal stress and this is shear stress, right? Now we need to take point such that which has normal stress and shear stress. Now any plane, there are infinite number of planes exist on this soil sample. Now we will take major planes through which we can draw Mohr circle easily. So major planes means what? Major or minor principal planes. What are those principal planes? The planes on which there is no shear stress. Those are called principal planes. Now here you can say, as there is no stress here, this is unconfined, sigma 3, let us take it as sigma 3 normal stress, that is 0 because it is unconfined. From here also this is sigma 3 unconfined. Initially here also there will be sigma 3, right? sigma 3, everywhere it is 0. Then next the test will be done under simple compression. Let us take that as sigma 1 at the end will be sigma d, which is called deviatoric stress. It fails under only deviatoric stress because there is no confinement. So sigma df, and same at the bottom also. Okay, these are initial. Now at the end this will be sigma df and sigma df. Now shear stresses on these planes they are also 0 here. Okay, now let us take it as this is tau xy and this is tau yx. Okay, now this is 0 and this is also 0. What do we need here to draw the Mohr circle? Sigma comma tau, 2 points which are extreme ends of the diameter of the circle. So the diameter of the circle, if you take those 2 planes which are perpendicular to each other, they will become the end points of the diameter. Now these are perpendicular, this plane and this plane are perpendicular. So I will take point on this plane first. So what is called 0, first sigma 0 comma 0. So that is here, and another extreme end will be the points on the another plane, stresses on the other plane. So this is sigma df comma 0, right? Because at the end while it fails, whenever it failure, so this is sigma df comma 0, right? This is 0 comma 0. Now if it is diameter, then you can complete circle, right? This is called Mohr circle. So now this test is done generally on the clayey soil, right? For clays, pure clays, friction angle is 0. Now what is the concept of the failure plane? This is the failure envelope. This is called failure envelope. Failure envelope is shear strength equal to C plus sigma tan phi, right? This is the straight line formula. This is the straight line. Here why did I draw horizontal line? Because here phi equal to 0, tan 0 equal to 0, so S equal to C. When S equal to C, this it will be horizontal, right? And C is what? Intercept. So as it is done only on the clay soils, and in undrained case it will be done, so you can call it as undrained cohesion. And here if it is under, then it will be, the shear strength will become undrained shear strength, which is also equal to undrained cohesion, because phi equal to 0, this term will become 0. So that's how SU equal to CU. And what is it equal to? Now here if you see, the sigma df is the only vertical compressive stress, and here according to the definition of the unconfined compressive strength, it is the load at failure, right? And sigma df is also stress at failure. So unconfined compressive strength is also stress or strength at failure, stress at failure. Now if sigma df equal to Qu, then what is Cu? How can we calculate? What should we do for this? Let's just see. So if this is the diameter is equal to how much? Qu. And this is equal to what? Radius, right? Because it is horizontal line and it is touching at the highest point of the circle, right? Now this will be automatically equal to Qu by 2, because Q is diameter, it is QU by 2. That's how CU is, or SU, undrained shear strength, equal to QU by 2. This is how we will calculate cohesion from the unconfined compressive strength. So let's move to the problem. So we can write the given data first. We'll write the given data first. Okay. What is given data? We have been given length L equal to 10 meters, right? Then ultimate capacity of the pile, this is ultimate capacity of the pile, compressive capacity, that is also given 632 kilonewton, right? Also we have been given QU value, if you remember, that is 100 kPa. Now from this we can, this is the given data. Now calculations. So what should be done first? What is the requirement? B, the width. Here you can see this is B, you need this. You have been given L equal to 10 meters. Now, so we can, first we need to know what is compressive capacity of the pile. So there, the compressive capacity of the pile will be the resistance which is offered by the pile through its screen friction, right? So there is a load from the top superstructure, that is downward direction, and to oppose that there will be screen friction which develops along the length of the pile. Okay, depth of the pile, you can say. So this is the front view, this is the front view of this isometric view of the pile. Okay, now the resistance can be offered by the surface of the pile, also by the end of the pile, which is called also tip. So this is called bearing, this is called friction. These two components will offer the resistance. Now from this we can write the formula. So bearing strength into area of the base, right? This is the area of the base, plus this is frictional resistance, right? Frictional resistance into surface area. This is surface area. Now Q equal to bearing strength. So you have been given bearing capacity factor and you have been given CU value. So sorry, you have not been given as of now. So if the cohesion is CU, the bearing strength will be C into NC into area of the base, plus frictional resistance. There is an addition factor, frictional, that is causing the friction. So that is alpha, and alpha times SU is frictional resistance into AS. Now what is C? CU. Here CU we have discussed already in the previous slide, that is QU by 2, 100 by 2, that is called, that is 50 kPa. Now can we substitute all the values? So in the given data I forgot to write this, NC equal to 9 also given, also alpha equal to 0.7 is also given. Now we will substitute all the values. CU is 50, NC is 9. What is bearing area? The cross section is what? Cross section is square cross section, it is B, all sides B, then it will become B square, and alpha is 0.7. SU is nothing but CU, I told you, this is 50, and AS, what is AS? Surface area along the along the pile depth. Now how many faces are there? along the depth there is 1, 2, backside of 1 is 3 and this is 4, backside of 2 is 4. There are 4 surfaces, each surface area equal to width into length. Okay, so now 4 into b into what is length? 10, right? Now this will be equal to 450 b square. This q is given 632 and 0.7 into 50 into 4 into 10, how much? 400 into 50, 2000 into 0.7 will be 1400, right? B. Now solve this equation. If you solve this equation, you will get B as 0.4. If you see, all the units are taken in SI units, kilonewton per meter square, kilonewton, and length is also meter, 10 meters, right? Because of that, the answer will be also in meters because B is a width. Now, which is equal to 400 mm. So this is the final answer, B equal to 400 mm. Thank you.